Hello and welcome. I'm going to have a go at this new free case by Jean Wolleh called Tree Climber. Link in the description to where you can download this free case and the 1 squillion other free cases that are now available. So, very quick intro to the case. It's called Tree Climbers. In this case, we climb trees. Diagonal, vertical, and horizontal movements are allowed. I'll just show you visually. The idea is that we walk along the ground, above this thing here, and then we can climb trees. And first we're just in, so we can't travel in the leaves, can't travel in the white. So if you want to get to here from here, then you go along, and then you go up the tree, and then you can make diagonal moves here and so on. But then later you also get into variable costs. So there is, the cost to climb up one section of the tree is bigger than the cost to climb down one section of the tree. Diagonal costs have different amounts and so on. So yeah, it's like a kind of particularly wacky maze case. I'm going to be starting from some maze lambdas that I already have, which I suppose makes this video less than perfectly accessible if you don't already have maze lambdas, but my maze lambdas are very similar to Bo's, and he's done lots of videos kind of demonstrating building those from scratch. So I'll include a link to some of those in the video description, but first I'll just show you at the start a quick idea of the two maze lambdas I have. So that, think of it as two kinds of maze problem. One is just counting steps. So either you can go in a square where it has a 1 in it, or you can't where it's blank. And maze is the one for that. So let's say we're going to start in B2. The directions, my arrow offset codes are the kind of 8 offset codes for -1 going to the left, 1 going to the right, -1,000,000 to go up a row, +1,000,000 to go down a row, and then -1,000,001, and all of these others for diagonals. For this one I don't want diagonals, so I'm just going to take that. Then my actual map is this, and my valid map is also this. Sometimes these might be A's instead of 1's, in which case my valid map would be something like that equals A. But in this case, I've set it up in the simplest possible way, and that generates this. So pretty straightforward. You just walk along the path. But for example, if you want to get to here, then you're faster to go this route. If you want to get to here, then you're faster to go this route. And here it's kind of equal between the two branches. And similarly over here. This one is a kind of simpler one to write, because at each step you can just say, okay, whatever, I'm here. What are the places I can get to from here? It's here, here, and here. Which of those have I been to already? That one, so I take it out. Now there's 2 new places, and I just add those on at one higher than the cost of where I've already been. This one, where the cost of a step is variable, is more complex. This would say, the cost to step into this cell is 10, the cost to step into this cell is 1, into this one is 6, into this one is 12, these are not accessible, and so on. And so for that one, I've got this maze variable cost, and again, we're going to give it the name of a starting cell, which is going to be B10. We're going to give it the valid directions, and again, I'll just take my array offset codes, but just restrict it to up, down, left, right. Sorry, arrow offset, not array offset. Then again, my map actual is going to be this, and my map valid is going to be this not equal to x, or is number of that, or whatever. And that, whoa, what? Oh, sorry. This isn't map actual, it's supposed to be map cost. So that is just this again. There we go. So you can see, for example, that I guess the higher complexity on the algorithm in this one is, if I say, okay, where can I get to from here? I can get to there for a cost of 10, or there for a cost of 1. And then where can I get to from those? Well, I can get to here from here, so that's a total cost of 11. Or I can get to here from here, that's a total cost of 20. I can get to here from here, total cost of 11. I can get to here from there, that's total cost of 2. So you could say, okay, now I can get to here for 2, I can get to here for 11 by taking the cheaper route, and I can get to here for 11. But by the time you wind your way around the longer but faster path, you can actually get to here in 10. And so with this one, anytime you record a cell, you just keep tabs of, okay, these are all the places I can get to in 5 steps, and then from there, these are all the places I can get to in 6 steps, and once you've locked in a step, it's done forever. Whereas in this one, you can get to this in 2 steps, but the more efficient way is to get to it in 10 steps by going around and around. And so with this one, you have to keep revisiting places that you've already been if there's a faster way to get there. But like I said, I'm not going to show you the workings of these today any more than I need to adapt them to work with this case, which is not what they were set up for. But Bo has some great demos of those if you want to see them. All right, enough yak. I am going to start the case. So first thing I'm going to do is just some quick setup, and I'm also going to demo a fun new robot command that I just wrote today. So I'm also going to unhide and zoom out on these just to make them a little easier to work with. There we go. And this one, zoom out and unhide. Okay, so the fun new robot command that I made is basically to create from a legend. So I'm going to say I want this to be T for tree, I want this to be L for leaf, and I want this to be an empty string. And then I'm going to copy this. I'm going to select the range that I'm interested in. Oops, all right, down to there. And then I'm going to call the robot command write color from legend. And it is going to, boom. Oh, interesting. It made those all 3s. So the way it works is if there's nothing, if there's no text in here, then it will just say this is 1, this is 2, this is 3. But I thought that having the empty string would make it behave differently. Anyway, whatever, I don't care. I'm just going to replace 3 with nothing. And that's fine. And I guess I'll put in, do I want to put in something different? No, I'll just leave it at that. And just do the find and replace on 3. So anyway, so I copy that again, and I come here, and write color from legend. Boom. And then I'm getting ahead of myself because this is meant to come up in a bonus question later, but on this one you'll see an additional feature of it. Let me just check that's still, no, it's not copied, so let's copy it again, and write color from legend. So what it does is it writes all the colors from the legend, it leaves NA in any spaces where it doesn't match, and then if at any point it flags along the way that it didn't match something, then it does a go to special errors so that it will naturally flag for you. So here there's actually a deliberate thing for a bonus question, because the bonus question asks in the large sheet, one cell has a slightly different shade of green than the others. What is the address? But this also came up, for example, on the Dach Lana Goes on Holiday case. Someone pointed out afterwards that there were, I think unintentionally, some of the black border cells were a slightly different shade, a different RGB code of black than the others. And so my usual kind of old way of color lookup failed on that, like returned NAs, but because it was black font on black background, I didn't even notice that. So this one kind of naturally draws your attention to, okay, you've said this is the legend, but actually this is not part of the legend. Anyway, for this purpose, I just want that to be L. I'm going to zoom back out again. I'm also going to replace 3 with blank. And that'll take a minute because it's big, but that's fine. And we'll do that here as well. Probably could have just left the 3s either, but anyway, doesn't matter. So now I'm going to select all of that. That's the medium one. I'm going to name it M. I'm going to come here and name the small one S. And I'm going to come here and name the large one L. Okay, now we can get on. So level 1 says you start in cell A28. How far is it to the given? Oh, sorry, which reminds me, you start in cell A28, which is the ground. I had some trouble with this one for a couple of reasons. One, because I initially thought this was the ground, but you're walking along the ground, so you're walking above the road. And second, because on the later levels we have the slowdown penalties for movement in trees, and I had tagged these tree, but also on the ground cells as t, because I figured, okay, if I'm coming from here and climbing up to here, then the way the tree costs work, it didn't actually make a difference whether I, walked over here and then climbed up or climbed directly up. And so I thought it didn't matter. But if I'm starting, say, from here and ending up over here, then I climb down this tree, walk across, walk through this tree, and climb up here. So it does actually matter whether I incur tree cost, and the correct interpretation is you do not incur tree cost for walking past a tree. So I'm just going to make the whole bottom row say G. Okay, so now you start in A28. How far is it to the given cell? So we're going to have a simple maze of A28. Directions are all 8 directions, so just say our offset code. The actual map is S, and the valid map is going to be S equals G plus S equals T. And that will tell you the cost of getting to each of these cells. And if you wanted, you could take this and apply the formatting, and you can see it's only taking you to the brown and not the green. But this is actually going to end up in getting rolled into another formula, so I'm going to take it out of there. So then here, I want to say what would these values be on that output. So I'm going to say add to ref of all of these on this. Now this is a calculated array, so it doesn't have a cell 04 or anything like that, but my address to reference function can say, based on the location on a given map, which in this case is S. I've done that as one formula just so that it only calculates the maze once. It does mean there's an NA there, but whatever. Okay, so that's level 1. Level 2, relevant sheet is still small. You start in the given cell. From there you have to go to the goal and back to the start. How far is it to the given cell and back? So this is just basically the same as this. We'll copy the formula. So we're going to start from here. We're going to go to here. And then the return journey is just the same thing again. So we're just going to double it. And that's level 2. Okay. Level 3, medium hard. Medium hard is it's an interesting interpretation for this challenge. But anyway, so from level 3 onward, certain directions have a time value associated with them. So far it's been the distance that's been asked for. Now it's all about time. Moving from cell to cell always takes 1 second. In addition, when you climb a tree, you're not as fast as when walking on the ground. So these are the different directions you can go in. So, climbing directly up, it says time required 7, but that's on top of the 1. So I guess I think of it as time penalty or something like that. Whereas climbing down only has a time penalty of 4. Climbing across has one of 3. Now these are not in the same direction as my arrows, I think. Yes, so I'm gonna just X match this against ours, and then just sort. That'll work better for me. Okay, so we're on medium now. Yes. Starting and ending here. I'll just bring those over so that I can do this one as an example. So then I'm going to go with, so I've got a maze variable cost to grid, which is the one I showed you, which returns in the same shape as the maze. But I've also got to list, which is this is the kind of inner one. So the grid one calls this one and then just does a lookup in this. So let me just show you over here. If I make this maze variable cost to list, it's the same arguments except that there's also a recursive call here to maze variable cost to list. And instead of giving you a grid like that, it gives you a list exactly like it sounds like it would, that says here is the row column code, or you can convert that to an address if you want. here is the number of steps it takes you to get there. So you start in B10, so that's step 0, cost 0. It takes you 1 step to get to C10 at a cost of 10. It takes you 10 steps to get to D10 at a cost of 10. It takes you, 15 steps to get to I10 at a cost of 20. So where even is I10? It's here. So the fastest way here is 15 steps, which is 15 steps, really? Okay. Anyway, whatever, doesn't matter. So this is the lambda that I'm going to modify to work with that. So let's just start off with maze variable cost to list. Recursive call is maze variable cost to list again. Then the start is going to be this. The directions is going to be arrow offset codes. The map actual is going to be M, and the map. What are we doing? Sorry. And the map cost for now. I'm just going to say M equals G plus M equals T, because that will filter for only being able to step in those places. Okay, it's looking like you can get to most places for free, which is okay. So let's just say if that, then 1, otherwise X. That should mean that we can only get to, yes, there we go. Now we can only get to accessible places. So that's my starting point. Now I'm going to edit that lambda. So like I said, I will show you what's going on under the hood to the extent that it is necessary to modify it to make it work for this. So this is just setup stuff. You don't really need to worry about it. The main thing is it's building this list. So it starts off with just the initial location, which is M46 converted into one of these codes, and 0, 0. And then at each step it figures out, okay, what is the highest step number, because all the whatever, if you've mapped out up to 15 steps, then to figure out what is 16 steps away, you're going to take all the places you got to in 15 steps and then go from those. So this figures out the maximum step number, and then you filter the most recently visited locations based on that, and you filter the most recent costs based on that, and then you figure out the next location. So the next location is going to be, you take the previous location and you add all the different directions to it, and this is down a column and the directions are across a row, so that gives you a 2D array of all the places you could get to next, and then you flatten that with 2col. Similarly for NXT cost, this is just broadcasting it, so we're multiplying directions by 0, so that you're just adding an array of adding a row of the right number of zeros that just broadcasts prev cost out to that. And then, so that's just kind of flattening the existing cost, and then you add to that this, which takes the next location and takes what is that RCRef as a reference on the map cost based on its location on map actual. So this is the bit, basically this is the new cost. This is the bit we need to change to take account of the to take account of the tree movement costs. Now I think there is an oddity that I think that if either your starting or your ending location is a tree, then where is this? Doesn't mention it in this one. It mentions it somewhere. I want to make sure I get this right. It just at this level you don't leave trees. There's somewhere, I'm sure, there's a clarification of that. I don't know. I guess I'll just try it and see if I match the answer, and if I don't, then I'll change it. And that will sort things out. Okay, so this is the cost that we need to modify. So now the cost is going to be just noticing that to check if it's valid, I'm using that. Yeah, is number NXT cost. Okay. All right. So what do I need to do? Okay. So the first thing is I don't want to work with the flattened version because I'm going to have the 8 columns of the 2D array before it's flattened correspond to the 8 different directions. So I'm going to need to apply the new cost in there. So, yeah. So let's just start with if yeah, so this piece I'm going to keep because my map cost is just 1 if you can get there and x if you can't. And adding this will make that an error if it's a place you can't get to. So there is always a cost of 1. And then there's also, if you're in a tree, there's an additional cost. So instead of adding dirs, I'm going to add plus. Then what are we going to say? We're going to say if rc ref to ref of rev lock plus dirs on map act. So that's going to give me, t if it's tree, g if it's ground, etc. So if that is equal to t, then I want to add 2 row of, I'm just going to call it tree pen. I'll have to go back and create that name in a second, but that's fine. Otherwise 0, because I'm adding the 1 out here. And I think that's it. Famous last words. Let's see. Now there are recursive calls in here that call the named function, so we'll have to save it before that will do a full fix, I think, but yeah, I think that's right. So then I just need to take this name and apply it to the thing over here. Okay. So now we can save lambda. Oh shit! Sorry, I didn't mean to overwrite my. Right, fine. Well, I've overwritten it, so too late. So now should be able to change this to a maze cost to grid. We've got something. Let's see what it looks like. Let's zoom in on a bit. So, okay, well, first of all, we've got 0 in the wrong place. Oh, sorry, we don't have it in the wrong place because we're not starting in the bottom left anymore. We're starting in M46, which hopefully is here. And it is. Good. Okay. So climbing up costs 8. Yes. Up and to the right seems to be costing 9. Oh, maybe that's right. Yeah, there's an 8 penalty for up and to the side. So yes, that costs 9. That makes sense. That costs 8, or 9 from there. That costs 9. Yeah. Okay, that seems to be working. I guess let's take it and try it out. So we're going to say take from the start to the goal. Okay. So maze var cost to grid of this. And actually, sorry, we can go back to list with the recursive call. And then we just want to VLOOKUP add to RCRef of this in there, returning from column 2. And that does indeed give 260. Hooray. Okay, so that clears that level. Same rules applies in level 3, only this time you have to go not only to the goal, but also from the goal back to the start. This one's actually, with my setup, a pretty easy adjustment. So we've got 427 to match, so we get 260 in that direction. And then we want to add the other direction, which is that one becomes that, and this one becomes that. And that gets 423, which I think is because you're not applying the penalty for the moment you climb out of the tree. So, how can I adjust the formula to allow for that? Maze list, edit lambda. So I think I just want to say here, where I say if that, I want to say that equals t plus so if your starting point is tree, then I also want to apply that penalty, meaning that. Save lambda. It's out of there, and yes, now it matches. Good. I won't leave trees. Anyway, whatever, I don't know. Cool. All right, level 5. The rules are the same as level 4, but you leave trees. You can climb from this to this and this to this. Ah, here we are. Yes, this is where it clarified it, although it is relevant in this level. But this is where it clarified. You can climb from L60 to M59. L60, which is here. So it's saying you can climb from here to there, or you can climb from here to there, but both of those have both directions still need the adjustments as you're climbing inside a tree. So that's what that's about. Anyway, so now I think I just take this down to here and replace M with L in a bunch of places. And everything else is fine. Maybe. Famous last words. Okay, starting to get a little slow to calculate as these take 1,000 steps, but otherwise fine. Okay, so now level 6, very difficult. This is the one that piqued my interest because Hayden said it was crazy hard. Relevant sheet large. The rules are the same as in level 5, but you've developed fear of heights. Climbing between lines 30 and 40 takes twice as long as climbing further down. Climbing between lines 1 and 29 takes 3 times as long. Fear of heights occurs when you enter the area. So if you climb from 41 to 40, it takes you double because you're moving into the fear zone. If you climb from 30 to 29, it takes you 3 times as long because you're moving into the extra fear zone. If you climb out of the fear zone from 40 to 41, then that's regular speed. And if you climb out of the extra fear zone, that's the middle penalty. So what does that mean? It means we want to take maze var cost to list and modify that. And this, like I said, I think with my setup, this is a relatively easy adjustment. So this piece is just the 1. Oh, sorry, the nuance, which I missed originally, it's clarified in the explanation, is that if you make a climb that would regularly take you 8 seconds, 1 second distance plus 7 seconds tree penalty, then it's only the tree penalty that gets doubled. So where I've applied the extra cost here, here. This piece is the 1, so that does not have to get multiplied, but this piece, the if, does need to get multiplied. So I'm just going to say times, whoops, daisy, times x lookup, and it's based on where you're going to. So that's prevlock plus directions, and I want to rcref to row of that. I want to look that up in an array that is 1, 30, 41, returning from. So if you match the lowest row number, meaning the highest height, that's 3, to 1, and I want exact match or next smaller item. And that's it. I think that's it. So then we're going to save lambda as, and we're going to call it, I don't know, maze L6. And wait, edit lambda. How does this one deal with recursive calls again? Oh, right, it doesn't. Cool. So then I want maze variable cost 2 grid. No, I don't even need that, do I? Save lambda. Wait, so this is, yeah, okay, fine. Then I can cancel lambda edit. So then I think that means I should be able to take this, put it here, and then change this to maze L6, and change the recursive call to maze L6, and then make the same change down in the second VLOOKUP. And is that it? That seems too easy, but it worked. And it'll take a second, but hopefully that's, yes, that clears it. Gives me 10 points. I've commented about this on Jean's cases before, but he is far from generous with marks. This is a very bloody hard case, and getting the whole thing out is worth 270 points. Anyway, how many leaves, green cells, are there in all 3 workbooks? So now that we've done the setup, that's just countifs S is L plus the same thing for medium plus the same thing for large. And I had to pause and think, but I have labeled the one that had a different thing correctly, so that's fine. In the large sheet, oh, you know what, I didn't keep a record of which one that was. It was somewhere in here, but I didn't. Oh, bother. Well, actually, you know what I can do? I can do this, copy that, and I think it was, yeah, somewhere in this middle section. So let's just do my right color from legend into that. Why on earth is that running so slow? Oh, right, because I've got so much calculation going on. Never mind. Oh yeah, there it is. So I didn't change the color, I just changed the label, and the answer is it's BD20. So that's lucky. But I think I did lose relevant information elsewhere, because this question asked about the apples in the trees, and I overwrote a bunch of values over that, so I can't answer that, except I can because I happen to have noticed earlier that the apples had this, vanishing format to make them not appear, so that when I type L in here, it does not show. So I guess I can say find by format, choose format from cell that, and Alt-I to find all, and that finds 8, which I think I do remember is the right answer. Why have we got an NA? Must have broken something along the way. Or else it should, okay, just needed a minute to calculate. And now this one is a particularly harsh score with 10 points available to work this out. So the question is, what is the maximum distance between a leaf green and a branch brown? Small, medium, and large diagonal movements are allowed. The additional nuance that isn't mentioned there is that you can only move through the green area. So I happen to remember that the answer is this cell, but I didn't get that one originally because this one is closest to this branch. So I'll just quickly show you. The way that I originally approached this was I have a dist from lambda that says dist from s, the target is t, and the function is diagonal movements are allowed, so the function is max. And that will tell you whatever this leaf is 5 away from the nearest branch, and so on. Same thing for all the others. But if you apply this one to the large map, then you get L, target is T, and the function is max. And copy the formats again to make it easier to read. Then this one is a 6 because it's about the distance from that. So you can't do that, obviously. So you have to do something different instead. I can't remember if my maze lambda can do this by itself, but let's try it. So let's say maze. I want to give it a variety of starts now. First things first, what does it do with the start? I think it can take a start as an RC ref or that's the distance lookup. Here we go. If is number start, then start, otherwise convert it to an RC ref. Okay. So what I want is to get the RC refs of all the t's, and what I can do for that is flatten. The condition is going to be L is equal to T, and what I want to flatten is row column of L. That gives me the row column numbers of all of those. So I'm going to take that. I'm not totally sure that I can do this with my maze one. I know I can do it with my maze variable one, but I'll try it with the maze one. So I'll put all of those as starting locations. Directions will be our offset codes, because you can go in all 8 directions. The map actual is going to be L, and the map valid is going to be, can I just say L equals leaf? I might have to also show that T is valid. I'm not totally sure, but let's just try that first. Oh, look at that. That just totally worked. So now we get a 7 there. Cool. Yeah, like I said, I couldn't remember if my maze could handle multiple starting points, but it can. And it makes sense because the algorithm is like you apply the same step whether you're starting from, one starting location or whether you're starting from 85 places that you can have got to by the 16th step. So that's fine. So I guess to do the bonus properly, we'll come over here and say it's going to be the max of that, and the same thing for small, and the same thing for medium. So medium, small, medium, small, medium, small, medium, and small. And that is 7. And that gives me a lofty, lofty score of 270 points. John, come on, really, just like mark them out of 7,000 or something. These are hard cases. Anyway, that was a very fun one. Like I said, it's not for the faint of heart because this was, not too hard, but certainly not trivial, starting from a pretty advanced set of maze lambdas. If you were starting from scratch, I don't know. Someone told me they did this. I think it was JJ said he did it with circular references, but he had to put the maximum number of iterations up to like 3,000 for it to work, because some of these paths among the large trees, if you start from here and end up over here, you go a long way. So there's a lot to calculate. Anyway, very glad I did that, even though I kind of blew it the first time. Super fun case. I just kind of really enjoy ones like this that just kind of push the envelope a little bit on what's possible. That's all I got for today. Thanks for watching. See you next time.